Well, I'm back for, I guess, the second to last of these videos, at least for quarter one. I'm Mr. Steele, and I'm here to work through another question on your Essential Skills quiz for the first half of Honors Pre-Cal. In this case, I'm going to be attacking question number 9 on your ESQ, as well as the ESQ model, which focuses on inverses, or as I titled it here, inverse relations. So basically in this video, I'm going to talk through the big ideas of inverses, as well as their process, the process to compute an inverse for a given function. Then we'll proceed forward and actually do the 3 examples that you're provided so that you get a good feel for how calculating an inverse goes for a function, as well as how to label it and everything else. So there's not a whole lot of extra stuff here. It's a pretty straightforward process as well, so why don't we just go ahead and dive in right away. So there were 3 key ideas that I wanted to address first, and I don't know, this is probably the biggest stretch as far as what key ideas really are for a particular topic, but with inverses it's very process-oriented. But to kick things off, I just want to talk about what an inverse does. Like, what is the point of finding or calculating an inverse for a given function? Like, what is it supposed to do? What is it going to accomplish for us? I think that's easily overlooked. After that, we'll talk about the how, the process, which is pretty straightforward. And then finally, we'll talk really briefly about functions and relations, which shouldn't affect us at all here, but I think it's still worth a quick little discussion. So to kick things off, first of all, what are inverses? Well, depending on when you learned inverses, or like sort of what part of inverses kind of clicked with you, you may actually think of sort of the visual language of an inverse, in which case that you might remember that an inverse is a reflection across the line y equals x from the original function. So in this case, if this was f of x, this would be f inverse of x, or could be. I mean, assume that I'm drawing it as accurately as possible. So there's a certain symmetry to it. Specifically, it is across the line y equals x, but that doesn't necessarily speak to its purpose. It's just kind of a visual way of recognizing one function's inverse from the other. The other idea you might have in your head is partly related to the how we actually compute an inverse, which is that you switch x and y. And in truth, that's not the worst tagline to throw on inverses. It gives you an idea about how to start the process of calculating one for a given function, and it gets that idea of inputs and outputs being reversed. That's really fundamental or foundational to inverses, but it doesn't necessarily explain what they do either. In a sense, what I want to point out is that an inverse is meant to allow for a particular result when you perform function composition. So effectively, if we have 2 inverses, or a function and its inverse, f and f inverse, if we evaluate f of f inverse of x, we're going to get x. And that's going to be exactly the same thing we get if we evaluate f inverse of f of x. So in a sense, that's what we're looking for. We're looking for the function that undoes the original function, but better put, it's the function that spits out the original input from another function, or from the original function. So to give you an idea about these, let's come up with 2 really quick inverses. So we could have as our 2 inverses f of x equals 2x, and then of course its inverse, which you could calculate, we'll get there in just a second, would be 1/2 x. Now if we take these 2 functions and compose them of one another, in other words plug one into the other, if we do 2 times the inverse, we're going to get the same thing as doing 1/2 the original function. In both of these cases, clearly we get x. And that means our original input, notice that both f of x and f inverse of x begin with x and then they get plugged in, it spits out that original input. So basically it allows us to go from an output back to the original input. That is the purpose of inverses. And in fact, there are functions that actually have that word inverse attached to them automatically. Think about something like sine of theta versus sine inverse. Sine inverse of sine of theta. Like, there are some domain issues that kind of pop up in there that you'll see in the second half of the course, but the idea is sine inverse and sine are going to undo one another. Like, they sort of reveal what's left over on the inside with, some exceptions. But there's our idea. We're trying to undo stuff. The second piece is the essential info of how. How do we find an inverse? In a sense, it's this line right up here. To calculate an inverse, we're going to switch the inputs and outputs, which in our case we typically kind of remember as switching the x and y. So for instance, if I have the equation y equals 1/2 x plus 4, and I want to find its inverse, the first thing I'm going to do is switch the x and the y. This will then be x equals 1/2 y plus 4. From here, in order to actually have the inverse itself, I'm going to solve for the original y. So I'm going to solve for y. So in this case, that would give us x minus 4 equals 1/2 y. And then multiplying everything by 2, we'd get 2 times x minus 4, which, yeah, is 2x minus 8. But in any event, that's equal to y. This would be the inverse of this. So in fact, we could even say y inverse if we wanted to. So there is, and again, that's an awkward notation. It looks like a reciprocal. You might want to even put an of x there, although it's not. No, it's not the normalist notation. But basically, there's your process. Switch x and y, solve for y. It's effectively a two-step algebraic process for us to get through, and the problems we're going to run into here aren't so complicated that you couldn't just think of it as those two steps, I would say. The last little piece we're going to talk about isn't something that's going to show up now, but it doesn't show up in any of the 3 problems on the ESQ model. I doubt that it would show up even on a plus ESQ if that's something that your course offers this year. But just to kind of point it out there, let me just remind you that there is a difference between a function and a relation. Specifically, in order for something to be a function, it has to pass. So it has to pass, and specifically it has to pass the vertical line test. Which means if we look at 2 different things here, if I draw this, you might be thinking, oh, that's kind of awkward, but no, it passes the vertical line test. This is a function because there's no vertical line that we can draw that's going to cross the graph twice, at least not based on what we see here. On the flip side, if we have in a different situation, let's draw it right over here, if we have this fails the vertical line test, so this is not a function. And again, I only am bringing this up, again, not because that's going to show up on here, but just to make sure that the vocabulary is in your ear, because I'm going to be really careful about calling these not necessarily inverse functions, but inverse relations, just in case something awkward happens. The typical place where this shows up just a little bit would be if you're trying to do the inverse of a square root. You sometimes end up with inverse of a parabola that can end up with some non-functions. So there's some complication there, and we'll talk about that when we get there. But for now, I just wanted to make sure that that vocabulary is in your ear one more time. Otherwise, though, I think we're ready to dive into the actual problems. I think doing these is a little bit more straightforward than kind of thinking about them conceptually. So our first function we're supposed to compute the inverse for is going to be f of x equals 3x plus 7. And the way I'm going to begin this process is by just switching out the f of x for a little bit and writing this instead as y equals 3x plus 7. Now this is a line. That means it is a function, but it also means its inverse is a function. It passes the horizontal line test, although again, that's not our focus here, just putting it out there. But now that we've got our original equation with x and y, we're going to switch x and y because we're trying to design and come up with the relation that takes the outputs of the original and spits out the original inputs. So in other words, x has to be equal to 3y plus 7. Now we need to solve for y. Like that's always our goal, is to get it to y equals. So I'm going to start making moves here. I'm going to subtract 7 from both sides. So I guess I should show that. Minus 7 minus 7. That's going to give us x minus 7 equals 3y. And now from here you've got a couple different options. I could see a lot of people dividing by 3. I think that's perfectly acceptable here. You would in this case get y equals x minus 7 divided by 3. But there are several others that are out there. I was tempted to do 1/3 of x minus 7. Or if you wanted to, you could distribute this stuff in. It would be perfectly fine as well. And get 1/3 x minus 7/3. So however you decide to do it is perfectly fine. I'm only going to write one of them as my final answer, but again, all of these would be valid. The last thing that I want to note, though, is since we were given f of x as our original function, to name its inverse, we should name that appropriately. So we're going to name it not y or y inverse, but f inverse of x. So in this case, I would say f inverse of x equals x minus 7 divided by 3. I think that's probably the cleanest version of the answer. But again, all of these would be acceptable so long as you have fixed f inverse of x to them. So that way it's very clear what function it's the inverse for, and also its original notation matches the original notation. Or the notation of the inverse matches the original notation of the function. So there we go. There's our first one. Comes out really clean. And if you wanted to test this, you could use composition to make sure that it plugs in and spits out x, but I know that it does. So I'm not going to bother. The second problem we're going to hit, also even degrees, so also 1 to 1, and what's called onto, which allows us to guarantee that our inverse is a function, but for us, we're not really concerned about that. Instead, we're interested in solving for just the inverse. Just what is that relation going to look like? So in our case, I'll begin it just like I did the first one. I'm going to start by writing this as y equals x cubed minus 8. We'll make the adjustment for the function notation at the very end. And now I'm going to switch x and y. And the reason why I do that is because we're trying to, of course, write this out so that we have a function that takes the original outputs and spits out the original inputs. We're trying to reverse reverse the flow of information, if you want to call it that. So now that we got it, I can start solving some pieces here because we got to get y alone. So when I do that, that's going to give me x plus 8 equals y cubed. And now here you could do it a couple different ways, but I think most people are going to do the exact same one. You're probably going to cube root both sides, in which case you're going to get y equals the cube root of x plus 8. But I will say if you prefer to write this as x plus 8 to the 1/3 power, hey, more power to you. Nothing wrong with that. The one thing that is wrong there isn't wrong so much as just kind of sloppy. We called this original function g of x. Let's call the inverse the appropriate name. G of x has inverse g inverse of x, and that's going to be equal to the cube root of x plus 8, or x plus 8 to the 1/3. So hopefully what you're seeing here is that this isn't notably difficult to do. It's pretty straightforward. It goes pretty clean. You're just switching variables and then doing a little bit of light solving, a little light algebra in order to work your way through. That's going to bring us to the final video in the final problem in this video, and that's going to be finding the inverse of the function x minus 5 squared plus 3. And just to kind of give you an idea about what it is we're calculating, because it does throw a little bit of a wrench into the problem. It's going to produce a situation where I'm actually going to write the answer two different ways, like two different versions of the answer that I think both could be acceptable for, depending on how intensive you want it to be. But basically, just kind of picturing this. If I start by drawing the line of symmetry here for a function in its inverse, and then I do x minus 5 plus 3, you can sort of see where the challenge is going to be here. Basically, as we look at this function, it crosses over those two pieces, but it just also causes some, challenges here. This is just kind of an awkward looking thing. So in other words, if I'm going to sketch the inverse, that inverse is going to look something like this. And the reason I bring this up now is just to point out that this is where a little bit of a discrepancy comes up, because while our original function, h of x in this case, was in fact a capital F function, meaning it passed the vertical line test, the inverse does not. Notice I can draw a vertical line. In fact, I don't even need to dash it. I can draw a vertical line. I know my verticalness isn't quite there, but notice that it hits two separate spots on this function. What that tells me is that h inverse of x is not a function. In other words, it does not pass the vertical line test. And you'll see why it is that that's the case algebraically in just a second, but it's not trivial that this function produces a non-function inverse, which does create sort of some ambiguity about how you want to express your answer. So like I said, I'm going to do the work, and then I'll show you both versions of the answer so that way you're covered in either case. And if you get marked wrong for one of these two, I'd recommend you just speak to your teacher so that way you can ensure that you get credit or at least clarify what the expectations are. Maybe individual teachers have different expectations than I would or another teacher would. So just be on the lookout. Now, before we get to all that, our first step is the same as it has been. I'm going to write this as y equals x minus 5 squared plus 3. And then I'm going to switch the x and y. So there's the x out. Now y is on the inside. It's like they've got a spy. There's a mole in here. A mole digs into something. Oh, I didn't even think about it. That's interesting. Never thought about why they were called moles. But in our case, we have what we're looking for. Now we need to solve for y. So the first move is pretty straightforward. We're going to get x minus 3, and all that's going to be equal to y minus 5 squared. But now here's our next move. And it's not the move itself that's a challenge. It's sort of what happens afterwards. We have a squared. We want to get rid of it. So I'm going to square root both sides. The problem is not on the right side, although depending on how you express this, there are ways you could express this as like the absolute value of y minus 5. We're not going to go into that kind of depth here. You could do it that way if you were taught that way. But there's our right side. The problem is on the left side, because we have that square root, we don't know whether it's positive or negative or not. Therefore, we get y minus 5 equals plus or minus the square root of x minus 3. Now, that's not the end of the world, because by adding 5 to both sides, we can actually navigate this really quickly. We'll get that y is equal to 5 plus or minus the square root of x minus 3, and that's going to give us our inverse here. We're going to get h inverse of x is equal to 5 plus or minus the square root of x minus 3. So that's the answer I would express if I was you, and that's what I'd be looking for if I gave this problem to my students. Having said that, there are teachers out there who might say that you need your inverse to be a function, even though it doesn't say that in the instructions, and if so, our culprit is related to the plus or minus. The problem here is, though, we weren't given any sort of restricted domain, so that way we knew which half of the parabola to calculate the inverse for. We don't know whether it's the positive or negative version. So although I said that there were multiple answers that would be acceptable here, I don't think there's enough information provided in this problem to express it the other way, which would be either a positive or a negative version. I think that by not including any domain restriction here, not saying, oh, only do x values larger than 5, we've sort of capped ourselves so that all we can produce is this version, which is not a function. And so that's the only thing that I'm going to tack on there for you as kind of a warning, a word to the wise. We don't have a function here, so we can't say the inverse function for h of x is 5 plus or minus root x minus 3. That fake function, it's not a function, that relation fails the vertical line test. But having said that, do keep an eye on things in the future, because if there is some domain restriction that only gives us 1/2 of that parabola, then basically this might be either plus only or minus only. So it's something to be on the lookout for. Very easy to overlook, I'm not going to lie. Less easy to overlook is the fact that we are finished. This video is complete. You've seen 3 good, strong examples of computing inverses from given functions. We've talked a little bit about sort of the why they're there, what they're accomplishing. We've talked about that process and how it involves switching the outputs and the inputs, which shows up as just switching x and y and then solving for y. And we've also talked a little bit about functions and relations, so that way when you look at problems like the third one you encounter here, you're comfortable sort of thinking your way through the dilemma of how to express that, whether you use the plus or the minus, etc. But for now, whether you're using pluses or minuses, I'm going to conclude this video. Thank you for watching. I hope we've given you some good quality instruction and some information to put in your mind as you prepare for this ESQ, particularly question 9, which focuses on inverses. And yeah, thank you for watching. If you have any questions, feel free to leave them in the comments. Like and subscribe. You can tell I've watched a couple YouTube videos today. And yeah, hope you do well on your Essential Skills Quiz model in the first half of Honors Pre-Cal. Have a good one, everybody.